Good evening, friends. Just a moment, let me switch on my video. Okay, so I am back with one more video on springs. Again, a request by one of the students. So, finding the speed of the block connected to the springs. When it comes to springs, many students have lots of doubts. Okay, so that's why. So, in one of the mails I received, some 2-3 students suggested me that instead of doing so many different videos, why can't you do a video specific to some topics? Okay, and these are some of our errors that we received. Okay, and the teacher also explained it, and why not we do it? So I thought of continuing with the problems on springs. So towards it, we already done 2 problems. The first one was, I hope you have gone through my earlier videos. The first one was finding the frictional coefficient. First one was, let me show you what was the first one. Yeah, I forgot on this. Yeah, find the maximum height reached wherein you have a spring. Then what you do is you have an object connected to it. Then you pull the object downwards, and as a result of it, the moment you leave it, it gets compressed. It compresses the spring. So what is the maximum height reached by the object? Okay, so misconception many of the students had it is that they just use the maximum height reached using projectile motion. It's something like throwing an object upwards. They did this and they made a mistake and they got an answer which is incorrect. And then I thought of explaining like why or what is the reason for it and how do you proceed with it. Okay, and then the next one is we also looked at yesterday. We looked at how do you find the frictional coefficient, when an object is sliding down an inclined plane. How do you find the frictional coefficient? So here, okay, we got some answers which said F equal to mu times n. The second answer which we got is okay. So when it is coming down, this was more of applying the forces in the spring. Okay, so they applied the forces, but whenever you have so the misconception here is that the upward force is equal to downward force, and they did this, which is incorrect, and therefore they had to use the energy equations. This is more about when to use energy and when to use forces, and that's what. So the incorrect solution was being worked out here. The corrected one was seen to be worked out here. Now today we will look at, okay, so what would be the speed of the blocks connected to spring? There's one more misconception. Some of them have it. This problem number is again a problem taken from HCV. Okay, one of the students asked me, sir, how do you take up the energy in a spring? Is it that when a spring gets compressed, the energy is positive, and when the spring expands, the energy is negative? So how do we go with it? Okay, so this is one question being posed. So I am doing this problem. Now, okay. So the problem reads like I have a spring, a block of mass m is attached to two unstressed spring, which is having two different spring constants, K1 and K2. Okay, as shown, the block is displaced through right through a distance x. So what I'm going to do is I'm going to displace this through right by distance x, which means now you're pushing this object like this, which means this spring gets compressed, while this spring expands. This is what happens. Okay. Then the block is displaced and the distance x is released. Find the speed of the block as it passes through the mean position. Now what happens when this compressor, there is a energy which has been given to it, and then it will keep this energy for some time, and later on it will release it. And as a result of it, this spring is once again it pushes the object like this. When it pushes the object like this goes in this direction, and it displaces this spring, okay, a little bit. And once again, when this gets compressed fully, it releases the energy like this. So this object starts oscillating. This is what can happen. Now, if this is frictionless surface, then definitely the object keeps on oscillating forever. Okay, this is what can happen. And if this has some friction, then definitely after some time it comes to rest. This is what should happen. Okay. Now coming back to this, this is a problem from HCV taken from work energy power chapter on 46 problem. Okay. Now towards it. Now what did the students do? The students made something like this. One spring is compressed, K2 is compressed, okay, and other expanded. One energy should be positive. They consider that one of these energy to be positive. So they consider that K1 is positive because it is expanding, and K2 to be negative, which is decreasing, okay, and as it is compressing. And as a result of it, they said that the difference in the energies, okay, E1 minus E2, E1 minus E2, okay, because if you have to compress this, then you have to expand this. You need to do some work, okay, and then they said E1 minus E2, which is half K1 into X square minus half K2 into X square should be equal to half MV square. The difference should be equal to the V square, MV square by 2. Okay, so this is the answer they have got. And in other words, equating these two, you get V is equal to X into square root of K1 minus K2 by M. So this is what they thought that this is how it should happen. Now, there's a misconception. The reason why it is misconception is because energies are never negative. Okay, energy cannot be negative. Now, if energy is not negative, so why should I have this? When I compress a spring, I have to do some work. Okay, when I compress it, I need to give something like some amount of energy. Now, when I expand the spring also, I need to give some energy. Correct? So there is nothing like positive energy, negative energy in the spring. If you want to pull the spring, you need to give some energy. If you have to push the spring, then the spring opposes everything. Okay, spring is not lazy. Spring says, okay, I don't, what you call, I don't like the changes in me. Okay, if I am an unstretched spring, I would like to be in the state. Now, if you push it, it opposes. If you pull it, it opposes. Which means when you say opposes, that means you need to do some work. Correct? So therefore, now the total energy given by the mass by pushing it across is nothing but total energy should now be equal to half K1 into X square plus half K2 into X square. Half K2 into X square. Right? So this negative should not come over here. Now, as a result of this, when this releases and when this compressed, when it comes to the middle position, let its velocity be V. Okay, this velocity, when you consider the velocity, this is the energy stored in the object now. Okay, this releases some energy. This energy is some of them is spent here, some of them is spent over here. So this should now be equal to half mv square, right? So equating these two, I get V square is equal to K1 X square plus K2 X square, mv square equal to, right? Or V should be equal to K1 plus K2 divided by M into X, and this is square root. The only difference is this has to be positive over here. Okay, so this is not a great problem. Okay, so but it gives you some fundamental insights. The insight here is that whether you push a spring or you pull a spring, you are doing some work. Okay, work is done by you, and the energy that you spend should be considered as positive and never a negative value. I hope you have understood this concept. If you have found this video to be useful, do like, share, comment, and subscribe to my channel for more updates. Thank you, friends.